Okay, so now the final part of polynomial, we are forming the cubic equation when given the roots. So at the start, we've always been finding factors or solving for x, right? But now we are forming the equation when the question gives us the roots. So for example, if the roots of the cubic equation are x equals to half, minus 1 and 3, we can form the equation with these brackets first. So how do we get these brackets? So let's say x equals to half, then we shift it over, x minus half equals to 0. And then we want to get rid of the fraction, right? We want to linearize it. So we can times left hand side and right hand side by 2. So 2x minus 1 equals to 0. Then that's how we get this 2x minus 1. Now we will do the same for x equals to minus 1 and 3. Then we'll get these two brackets also. And if you notice, you must include an a in front unless the question has told you the coefficient of the highest power. So why? Let's say we have like x minus 3, x squared minus 3x plus 2 equals to 0. Now if we use our calculator to get our roots, we will see that x equals to minus 1, x equals to 1 and x equals to 2. However, let's say we use this same equation, but we times 2 by the whole thing. So we just add a 2 in front. Then we'll end up with 2x squared minus 6x plus 4 equals to 0. Now if we key this into our calculator and then we find the roots of this equation, right, we'll note that x is still equals to 1 and x is still equals to 2. That's because we can just factorize the 2 out and then we'll still get our original equation. So that's why we have to include an a in front. So if one of the roots is an unknown, we can still form the equation using remainder of factor theorem, which we will see in the next example. Now the term containing the highest power of x in a polynomial fx is 2x cubed. So they have given us our highest power coefficient. Now the three roots of the equation fx equals to 0 are minus 1, 3 and k. Given that fx has a remainder of 20 when divided by x minus 4. So when you see this, you obviously think of remainder theorem. Find the value of k. Okay, so we'll start forming our equation. So since the roots means x equals to, right? So x equals to minus 1, shift it over, x plus 1 equals to 0. This is our factor. Then we'll do the same with 3 and then with k. So x equals to 3, shift it over, this is our other factor. X equals to k, shift it over, this is our factor. That's why we have these three brackets here. Now don't forget your a in front, include it here. But since the term with the highest power is 2x cubed, so 2x cubed will be equals to ax cubed. Because when you expand out all these, you'll get ax cubed. That's why 2 equals to a. And then to find k, you can use remainder theorem. So from x minus 4, you let equals to 0. Then you get x equals to 4. Then you sub x equals to 4 and then equate it to the remainder of 20. And then you will solve for k and then you get k equals to 2. So now you sub back your value of k into your fx. And then this is part 2. Now note this explanation part here. When divided by linear factor, ignore this part, change it to remainder theorem. So don't use long division when you don't have to expand your polynomial, like expand all the three brackets. Always use remainder theorem, then you can avoid doing that and save a lot of time. We will have to find the remainder when fx is divided by x plus 2. So in order to find the remainder, we have to sub x equals to something. From here, x plus 2, let it equals to 0, then we shift the 2 over, so x equals to minus 2. So now we know to sub x equals to minus 2 into our fx, and then we'll end up with minus 40. So this is our remainder. That's why our remainder is equals to minus 40. And of course, you have to specify once again by remainder theorem.